In this tutorial, you will learn how to apply stoichiometry to the limiting reagent concept. Just a reminder, the word reagent is a synonym for reactant. In the limiting reagent concept tutorial, you learn that the limiting reagent is the reagent that is completely consumed in a chemical reaction. It limits how much product that can form, and therefore tells us how much product is made. After the limiting reagent is used up, no more product can be made. There is often an excess amount of the other reagents that will be left over when the reaction is finished. For an examination of limiting reagents at the particulate level, refer to the limiting reagent conceptual tutorial. Often when presented with a limiting reagent problem, we are given the moles or mass of reagents available. With this information, you may be asked to calculate the amount of product that can be formed, identify the limiting reagent, and determine the amount of excess reagent left over after the reaction has gone to completion. When presented with these questions, students may have incorrect ideas about the limiting reagent. These assumptions include the following. The limiting reagent is the reagent with the smallest coefficient in the balanced chemical equation. The limiting reagent is the reagent that has the least measured amount of grams or moles when beginning the reaction. It is incorrect to make these assumptions because there are multiple factors that relate reagents and products in a chemical reaction. We need to consider the measured amount of all reagents, the balanced chemical equation, and sometimes the molar mass. This often requires calculation. For these calculations, we can use stoichiometry, or the relative quantities of reagents and products that are involved in a particular chemical reaction. Let's return to our s'mores analogy to help us better understand how to solve a mathematical limiting reagent problem. To make a s'more, one must have 2 graham crackers, 1 chocolate bar, and 1 marshmallow. If you have 8 graham crackers, 5 chocolate bars, and 6 marshmallows, determine the following: the number of s'mores that can be made, and the limiting reagent. To solve a limiting reagent problem, you must have a balanced equation. The balanced chemical equation allows us to relate the amounts of reagents and products involved in the reaction. Our s'more equation is 2 graham crackers plus 1 chocolate bar plus 1 marshmallow makes 1 s'more. With the balanced equation, one method to solve for the limiting reagent is to calculate how many s'mores can be made with each ingredient. The ingredient that makes the least number of s'mores is a limiting reagent. Pause the tutorial to solve for the limiting reagent. Let's calculate how many s'mores can be made with 8 graham crackers. In stoichiometry, always begin with the measured amount. Start with 8 graham crackers. To convert graham crackers to s'mores, use the coefficients from the balanced equation. Write 2 graham crackers on bottom to cross-cancel the units. Write 1 s'more on top. With cross-canceling, the units we end up in, s'mores, is the units of our answer. Plug this into your calculator to get 4 s'mores. Here is the stoichiometry setup for the other ingredients. The least number of s'mores that can be made from these ingredients is 4. Once we make 4 s'mores, we are out of graham cracker. Therefore, the graham cracker is a limiting reagent because it limits us to only making 4 s'mores. The chocolate bars and marshmallows are the excess reagents. Some will be left over after the s'mores are made. Now that we know the limiting reagent, calculate how many marshmallows will be left over after the 4 s'mores are made. If we started with 6 marshmallows, we can subtract how many were combined with the graham cracker to determine the amount left over. We can determine the number of marshmallows used by calculating how many marshmallows combined with the graham cracker. Always start with a measured value. We will start with 8 graham crackers. To convert graham crackers to marshmallows, Use the balanced equation. Place graham crackers on bottom to cross-cancel the units. Write 1 marshmallow on top. Plugging this into our calculator, we get 4 marshmallows. So we can say 6 marshmallows at start minus 4 marshmallows used equals 2 marshmallows left over. We can relate this analogy to a limiting reagent chemical reaction involving a mole-to-mole conversion. Consider the following reaction between ammonia and oxygen gas. If 18 moles of ammonia were mixed with 20 moles of oxygen, determine the following: the moles of water vapor that will form, the limiting reagent, and the moles of excess reagent remaining after the reaction was completed. To determine how much water vapor will form, we start by determining how much water vapor can form with each of our reagents. Let's first calculate how many moles of water vapor will form from ammonia. Always start with a measured quantity. The measured quantity given to us is 18 moles of ammonia. To convert moles of ammonia to moles of water vapor, use the molar ratio from the coefficients in the balanced chemical equation. The equation says that for every 4 moles of ammonia reacted, 6 moles of water vapor will form. Put moles ammonia on bottom to cross-cancel the units. The units we are left with, moles of water vapor, are the units of our desired answer. Plugging this into our calculator, we get 27 moles of water vapor. Pause the tutorial to calculate the moles of water vapor that can be formed from 20 moles of oxygen. Here is the stoichiometry setup. While 18 moles of ammonia will form 27 moles of water vapor, oxygen will only form 24 moles. Therefore, only 24 moles of water vapor will form. Oxygen is a limiting reagent because it limited the amount of water vapor that can form. Now we can calculate how many moles of ammonia were left over after the reaction was completed. If we started with 18 moles of ammonia, we can subtract the number of moles that reacted with the 20 moles of oxygen to find the number of moles left over. Begin with the measured quantity of 20 moles of oxygen. Use the coefficients from the balanced chemical equation to convert moles of oxygen to moles of ammonia. Put moles of oxygen on bottom to cross-cancel the units. The units we are left with, moles of ammonia, are the units of our desired answer. Plug this into your calculator to get 16 moles of ammonia. From this calculation, we know that 16 moles of ammonia reacted with 20 moles of oxygen to form 24 moles of water vapor. Because we started off with 18 moles of ammonia, we can say 18 moles ammonia at start minus 16 moles ammonia used equals 2 moles of ammonia left over. Now you know how to solve a limiting reagent problem when given the moles of reagents. However, what if you are given the mass of reagents and are asked to find the limiting reagent? To answer this question, refer to the limiting reagent grams to grams tutorial.